Hi guys, now I'm dealing with lesson 2 dot plots, the same chapter 15. I need from you to remember something with my warm-up. I have to remember how to make frequency table or dot plots, something easy. We'll know it today. We'll take the introduction to this lesson, just attention, we found this easy. I have example to length of a snake in centimeters with this slice 11 9.5 and 9 10 9.5 many things. So I have to put the number line. You found every number here. If we make it increasing by 0.5 will be good, like 9 9.5 10 10.5 and 11. So we have to count how many nines we have here. I found just one 9. If we count how many 9.5, we found 1 2 3. It's just put we put dot or x like this. So sometimes we put dots or sometimes x like this. So this might represent as dot plots. I think it's easy. If I want to make it as frequency table, we make the numbers like this in a table. We'll see that. Now we're going to dot plots gives a visual way to organize and interpret data. You can also use frequency table to organize the data. So the frequency table is a list of the possible data values and how often each value occur here mean happen. So each value occur. So we're going to the first example, create dot plots and frequency table, both of them. The statistical question here, how many chapters did you read last night? The question we have was asked to students in a book club. The number of chapters read were, like this example, I give you many things as survey or something for the students in this club. So we have to count it and make it like frequency as a list. This is my list, the number of chapters 0 up to 8, and I have number of students. So I here dealing with this one, I take the smallest number here and I arrange it 0, then 1 2 3 4 5 8 and so on. We make it as order here, then we count how many zeros we have, 1 2. How many 1 we have? The number of ones here is 3 1 2 3. How many 2s? 1 2 3 4 and 5 0. So 1 2 3 4 5. 1 2 3 4 5. So it's clear to make it a frequency table is not new. The number of students, we count how many this number repeats. So I found it repeated 5 times. This is the number of students. Now to make it as a dot plots, so I make it again from 0 up to 8 on the number line. This is the number of chapters. Then I have how many numbers here too, so I have to make 2 dots here and 3 dots, 2 5 dots, and 3 1 dot, and so on. Now example number 2, a class of students was asked the statistical question, how many hours did you study from Monday through Friday? This means week, day. So we dealing with days in this week. There's response are shown. I give you the response for this for all students like this for. So we have to arrange. This is the first time I have to arrange from smallest to greatest. Will be good. Okay, like this. So I construct and interpret a data plot from this data. First order the data values from least to greatest, like this one. So 8.5 8.5 8.5 999. I have to arrange all of them and try to count well. I have to check how many values I have. So we have many ways. We have traditional way, we have to count, or you can make 3 here and 10 here. So 3 and 1 2 3 4 5 6 7 8 9 10. So 3 times 10 30. There are 30 data values. The least number of hours is 8.5 hours. The greatest number is 16. So this is my smallest number, this is my greatest number. So how to find here my number line? I have to make it as an order. We have here, we start with 8 because the smallest 8.5, and we have the last number is 16. So I have to make it 8, 8.5 will be good because we have 0.5 here. So I start with the smallest as 8, then I add each time as 0.5. So this is my 4. The number line for dot must be created using interval. Interval means the same distance. I add each time the same number, 0.5, all the time. Now we take the same. I need to make my number line or dot plot. So we have to make the number line again, or take the number line and count how many 0.5 I have. 1, 2, 3, 4. And here how many lines we have? It's about here 5. So I make 5 points. Then 10, then 11, 11.5, and so on. I have to count it here. I found everything. If I make this order, it will be clear for me to make my dot plot. Next example, we make something else. So we take the same number line and make questions about this like this. Interpret the dot plot here. So I give you some questions here. You have to answer from this dot plot. So how many hours did the greatest number of students study? So I have to see where is the greatest number is here. So this means I have here 10 chapters here. So this means the data value here with the greatest number of dots is 10 hours. This is my number of hours. And now we're going to another question. How many hours did the least, the smallest? I have two lists here, 11 and 11.5. This is my second question. Now we're going to another one, the last one. What do the values with no dots above them represent? So no dots mean we have 9.5 here, 10.5, 12.5. So this means for me the study time for all 30 students is shown on the dot plot. This is the dots. But the other mean no students. So the studies here, this time no one studying this time. So this means no students, means 0 students. Now we're going to another thing. What do you notice about the variability here? You found something here. The data shows a variability as the point as spread out. I found my spread out here. This part is we have gaps or distance between them without answers here, without dots. So we call this as spread out. So we're going to the range. How to find my range? We take the greatest value minus the smallest value. 16 minus 8.5 is 7.5. This is my answer. So we have now something new. If you look into this number line, you found something strange. We have here spread out, I told you this before, this small height for this dots, and found we separated here with gaps here or line without dots. This call for me as a tail. We call this as a tail. And this or spread out. And this is collect this place. We have many points in this place. So we call this as cluster here. So we have cluster and we have here spread out. If the spread out's right, so I have a skewed right distribution. I have again a skewed right distribution. Because the data value are clustered on the left. We have crowded here in this place. But here we have spread out, we have distance, and here we have gaps here. So the spread out at right. Because I have spread out right or tail at right, so I have here right distribution and skewed mean without, or we have difference or gaps here. Now we're going to the other thing, the opposite. We dealing with skewed right distribution. Now we make with left distribution. So this the second definition here. Skewed left distribution mean I have a tail or I have spread out at left, the other direction. If you imagine this part will be here and this part will be here. I'll make table for this to make a conclusion about everything, but not now, after 2 slides from now maybe. So there are fewer data, So the spread out meaning fewer, means small number of dots on left. So this part will be left. And the cluster, the most of the dots will be right. This is the cluster. So the graph appears to have a tail on left with this kind. Another example, we complete the same example but with another required. The same class of students was then asked the statistical question, how many hours did you study last weekend, the other weekday? So we're dealing now with weekend. The dot plots shows their response. So I give you this dot plots or number line to know the answer or response for the students, for all the students. Now we have the number of hours and the weekend study hours. So we have to discover something is very interesting here or very clear for all of you. I found all my heights, all my points are the same, look like equally. So if I need to answer this, what the pattern do you notice about the variability of data here? So the data here points are spread out. Yes, all of them spread out because all of them is close to each other, but we have here no difference here because it's very close to each other. So I make it as spread out. So we're going now to another thing, the range. I told you before, the range, the greatest value minus the smallest value. So 5 minus 0 is 5. So this is my range. Now we're going to the distribution show variability because we have different answer here or different student with different answer for these questions. So we have a number of study hours in different forms, student to student. This the way because we have variability. What do you notice about shape of distribution? I told you the shape of distribution is here equally. This equally has a new name. So this the third name today. Uniform distribution. So uniform distribution means we have equally or look like equally values or dots here. So the definition for uniform distribution has data values that are equally spread across the range. Equally spread. So equally we have a spread here, but equally little bit across the range. Now we're going to example 4. Example 4 is a comparing between example 2 and example 3. So we have to compare both of them. So I bring the dot plots for the two example 2 and 3 in front of you to compare between them. I give you something to answer or to give me your opinion about this. What are the similarities and differences in the two dot plots? So I have to compare. So first, pause dot plots include study time with unit of 0.5 hours. If you look here, you found we add all the time 0.5, and also here we add all the time 0.5. The second thing, therefore, the scale for pause dots 0.5, I have to discover something. Pause dots have 30 students value. Here 30 and here 30 also. So the same number of students. 2. The dot plots of studying during the week has greater range. So this during a week mean this one during the week, but this is the end of the week. So here I found something is very clear. The 16 and 8.5, the range we bring it in example 2 as 7, right? 0.5. So this is my range, and here my range 5 minus 0 is 5. So this is the greatest range. This difference here, something is very clear. So we have similarities and differences here. So we're going to another thing. So this is that. So if you found here, you found the number here is different little bit because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you found here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days. So different days. So this means that they are greater than on the weekend. Now we're going to another thing. The dot plots, this is the difference here. In weekday study hours is skewed to right. Why? Because I found here spread out here and we have cluster here. So we have cluster and we have here spread out. So we found here tail right. So this skewed to the right. Okay. So my skewed here, the skewed here is to the right. And symmetric in the same time. You found here 3, 3, 2, 2. So at the same time the tail is symmetric. the tail symmetric. See, this is the uniform one because I told you it look like equally. The dot plus for weekend study ours is uniform and close to symmetric also because we found they are symmetric. We have three here, we have here between them symmetric, so this look like symmetrical. Now this the table which collecting all the ideas in this lesson. Uniform distribution. How to know this uniform distribution? I found again my distribution where the observation here are equally spread across the range. This look like equally or sometimes equally. Normal distribution, like the last lesson, lesson 1, we take it before, is like bell here. So symmetric bell shaped as a bell. If you imagine you make here a curve here, you have a bell, something like bell. We have peak here at the center. This now we'll talk it together in lesson 1. Skewed right distribution. I found here my spread out or the tail for this one is at right, but here the callus left. So if the tail of this number line or this points right, so this right. So this is skewed right, but this skewed left. Why? Because my small numbers or the few numbers here are left, so this left kind. Okay, I think everything is clear, and this table make it more clear for you. Now we have examples here, like this example in page 583. I give you to complete your table. I think it's easy. Just count how many ones. Now the time of vegetables bought by canisters at farmers market. Let's broccoli, carrot. Let's corn, broccoli, and so on. You found here we make listing table here, frequency table, vegetable numbers here. The broccoli here, if you count the broccoli 1, 2, 3, I think 3, so the 3, and carrots, if you count the carrots here 1, 2, and I think also 3. The corn here 2, and we have something missing, we didn't write it here, is green beans. So if you count how many is just 1, the next here is about 1 of them 5. So this is my. So here I put the two tables, the table of the children, the last example, and this example together because I have to make the two dot plots, the number 9. So this for the first, the age of children, from this table I will make this, from this table I will make this. So I bring this from the other page to help me to make my number line. So here I have 1, 0, there's nothing here, nothing here. So I have start with 3 with 1 point, and 4 with 4 points, and 5 here with 2 points, and so on. I think it's easy to make. The same with this table, the vegetables here, farmers market. So I have to make, if I found the number is 3, carrots 3, corn 2, green beans 1, and let's here is 5. So this my tables and also my dot. Now I take the number line and dot plots to answer this. The data points are here, I think spread out. So this is spread out. And the range, I take the biggest number minus smallest number, 10 minus 3 is 7. The data here distribution is shows variability because different answers here. I have this variability. Which vegetable, so I have to take the other table, or you can use the other dot plots to answer this. So which vegetable was bought most of, mean the biggest number here is here less, and which vegetable was bought least of, means this green beans because it's the smallest number here is green beans. Now we're going into another example. Create a dot plot for data set the number of bits which family in grade 6 has. The number of fields here, we have many numbers here, 2 to 1. I have to arrange it if you can, so you make it from 0 up to 4, and you count how many zeros, how many 1, how many 2s, and so on. So the number of fields we're dealing with, so I have to complete from 0 up to 4. So 0, 1, 2, 3, 4. This is my numbers, and count how many zeros we have. It's about 5. and here 1 is about 4, and this 1, 2, 3, 4, 5, 6, 7, and here 3, no 3 here, so we dealing with 4 is about 3 fourths. Now we're going to another look at the dot plot, fill the answers, and we dealing with this dot plots and reading by 6th grade students during the school year. The dot plots show what? This is skewed here right distribution. Why? Because my few amount here right. This my spread out as right, and my cast will left. So this is skewed right distribution. There are how many observations, how many students here. So if you count all of them from here up to here, you count all of them is 20. The lowest data here, the smallest thing here was 4, and the greatest here was 1. The range I told you before, greatest minus smallest, so 5 minus 1 is 4. Now we're going to another example. The dot plots show what? You found my few number, my spread here left, the tail, this number line left. So this, yes, skewed to left distribution. The 20, if you count all of them, you found 20. The lowest data here, you found 4. Now page 586, we have to fill these gaps here with these answers. I have to arrange it and know the numbers of 55 and so on. If you can arrange it, you can just count to save your time. So you found how many 55 just 1. If you complete this, it will be easy to complete it, I think. Now I give you another one. I give you the numbers. You have to put it as a list. So I start with the smallest to greatest number, and I have to check how many I have at this. So the number of frequency of the repeated here for 3, just here I make it like this, just 3 and 4. So we found 1 4 here, and number 5 4, and number 6 just 1, 7 just 2, and 8 3. Make my number line. So 3 is and 4 is 1, and 5 is 4, and so on. You found is easy. Another example is the same idea. We count it, we arrange it, we make our own dot plots like this. So you have to discover this. The smallest number is 3 here, 3.5, but I make it 3 up to the greatest number is 12, and you add all the time 0.5. I think you discovered now the way. Okay, so this page 587, the same page, and you count how many 3.5. I think this I arranged for you here. I think you can make it alone, and you count. So this 3 and 2 and so on. So we have everything. Now the last page. Finally, the type of distribution. Fewer data value left. Fewer at left means that the spread out at left. The tail left. So the square is left. So this is your answer. Which set is uniform? You found here is the repeating for 30 just 1 repeat. So this the uniform we have just at least 2 repeated here. So 1 repeated is doesn't work with me. Here I have 1 8 1 9. It does not work with me also. 10 10 11 11. This 10 again 12 2, but 4 24 and 26 just 1. So this doesn't work with me. So the best one here is this one. So 16 16 19 19 17. So we found each number here is repeated. So this we have here equally and repeated symmetry. So this the good one here. Okay, so this the good answer. How many dots was 25? So how many 25 you have? This is the main for this question here. So 25 is 25. 25 I have about 4 now. Thank you, and make the homework. The same idea here. Homework is page 173. Is enough for me, and make this. Thank you for watching, and study hard this lesson.